Hello everyone, we are at Beyond the Formula. Let's continue conic sections with hyperbola. So far we have seen parabola, then ellipse, then circles. Now let's move to hyperbola. Now to understand hyperbola, we have seen ellipse, right? Consider if this is an ellipse with two focus, say f1, f2, right? And we have suppose a general point P. So this distance Pf1 plus Pf2 was constant, right? Now if we change this relation, say if I say the distance from the two focuses, say Pf1 and Pf2, their difference, their magnitude of the difference equals to constant, then what will be the shape? The shape of the conic so formed will be a hyperbola. This is the hyperbola. Now what happens here is the distance. See, it also have focus 1, focus 2. Now if I take general point here, say P, then this distance and this distance, the distance Pf1 minus Pf2 magnitude equals constant. Now this distance here is also, it is 2a, which is the length of major axis, right? Only here we do not use the term major axis. Here we do not use the term major axis. What is the term we use here? Any guesses? So we use what? We use transverse axis as major axis and conjugate axis as minor axis, right? So it is nothing but transverse axis. Now let's see the geometrical representation. Suppose we have a coordinate system and we have this hyperbola with focus f1 c comma 0 with focus f2 minus c comma 0. Now this distance, these are called vertices, so we'll have the coordinates as a comma 0 and minus a comma 0 with origin as the center. Now we will draw two asymptotes. What are asymptotes? The tangent at infinity. The tangent at infinity is called what? Asymptote. Now we will take the vertex and draw a perpendicular. Draw a perpendicular to the x-axis. The point where it cuts the asymptotes, we will draw another perpendicular to y-axis. Right? This distance. Now this distance at the y-axis is called b, and this point will have coordinates as 0 comma b. Similarly at bottom side, this distance 0 comma minus b, 0 comma minus b, and this complete length will be called as conjugate axis, right? Now let's move here. You see in the ellipse, in the ellipse, in ellipse, we have used a relation. What relation? We have used a square minus b square equals c square, right? But in hyperbola, in case of hyperbola, the relation changes to a square plus b square equals c square. Why? Because here, the focus or foci lies outside, or you can say the c is greater than a here. Okay. Now let's move to the equation part.